Good day. We've been speaking a lot about units and dimensions and conversion and those sorts of issues. One of the things that one must do anytime you do any measurements is to be able to convert from one system of units to another. And this is typically kind of a nightmare for people. For example, for measuring temperature, we have basically two unit systems that we use in this country. The primary one, of course, is degrees Fahrenheit, while the other one is degrees Celsius. And there are all kinds of there's all kinds of agony about trying to be able to convert from one system to another. So fortunately, there are standard rules that let you do that, but these can be sometimes quite complicated. In the case of temperature, for example, conversions of temperature, you have to multiply by some complicated factors and divide by others and add 32 and so forth. And we'll just leave that there with the understanding that this is a complicated process. One of the nice things about SI units is that it provides actually some simple methods to be able to do these kinds of conversions. And what I'd like to do in this module is to outline some of the ways in which conversions can be made relatively painless, but also can be used as a way of analyzing particular kinds of physical systems and in ways that can give you some insight into what these quantities are. Okay, so let's take the basic problem here of conversion. Let's say I want to figure out what the conversion is between one unit of measure in the English system, which is the yard, and the length of something in another measurement system, which of course is the meter. One is English and the other one is metric. Right? And how is it that you actually convert those one to another? Well, in the past we would do things like look at this at a reference book like this. These are conversion factors that are published, and they usually will give you nice tables for actually quantifying measurements of length. Here's one for length right there. Let's zoom in on this so we can get a better look at this. And what we have here is we have a table, basically a matrix, that lets us take a unit of one measurement and turn it into another. And so let's take a look at what you have to be able to do to convert the units of yards into a meter. All right. Now here is yard over here. Let's zoom out just a tiny bit so we can get all these numbers in there. All right. And if I have X number of yards and I want to convert those to meter, we just follow the table. Here's yards right here. To convert that into a meter, you multiply that by 9.144 times 10 to the minus 1. All right. In other words, 1 over 9.1440. And sorry, 0.91440. And you can just take that number, and if you have 5 yards, for example, you multiply that by 0.91440, and you end up with a certain quantity of meters. Now, there's some disadvantage to this. Sometimes it's unavoidable because if you're going to use this kind of method, you have to carry around a book like this, for example. The advent of the Internet has made this a little bit easier. There are various kinds of calculating engines that are available on various kinds of websites that either will tabulate all these factors for you, or they'll actually have a Java script application in there that will let you type in a number, and then it'll spit out a number for you. For those kinds of mechanical types of conversions, it's actually very easy to convert one number into another. You simply have to have a conversion factor. You multiply or divide by the conversion factor, whichever is appropriate, and you end up with the right unit. And while that's a perfectly serviceable way of doing it, it really is kind of a mindless exercise. It doesn't really give you insight into some of the things that are going on in these calculations. So, and sometimes you're out there in the real world and you don't have your handy matrices handy, or you're not close to a computer hooked up to the Internet. This is particularly an issue when you're doing field biology, and so you have to have some way of being able to convert things from one to another by calculation rather than looking up a number in a book of some sort. Now, in this instance, you can treat units as mathematical quantities just like you treat dimensions. And there are certain rules that apply to the mathematical operations you can do with units, and there are certain rules or certain operations that you cannot do. So for example, you can take units of any kind and you can multiply them together. All right. So for example, if we have a quantity x and that is measured, that has dimensions of length, for example, and we measure that in meters, then we can multiply that by a quantity y that, say, has units of mass, for example, that is measured in, that has a dimension of mass, but that is measured in units of kilograms. You can multiply those together, and just as you'll get a dimension, which is L times m, your units for that multiplication will come out to be meters times kilograms. So you can multiply units just like you can dimensions. You can also divide units just as you do dimensions. So for example, if you have a length measured in meters, you can divide that by a time, quantity y, that is a time measured in seconds, and what you'll end up with is something that has dimensions of length times time to the minus 1, or units of meters per second to the minus 1. And you'll recognize this as the units of speed. So you can either multiply or divide units, but you cannot add them one to another. And so, for example, if you're talking about an operation like this, where you have a quantity x that is dimension of length measured in meters, you cannot take that quantity and add it to a quantity y that has a dimension of mass that's measured in units of kilograms. You cannot add or subtract dimensions, and you cannot add or subtract units. You can add or subtract two numbers that have the same units, but you cannot add or subtract numbers that have different units. Okay, now let's go through some handy little rules and operations that help us understand how these kinds of conversions work. All right, let's take a simple one first. All right, let's take the problem of converting meters. Okay, all right. So let's take the simple one first. Let's take a conversion of a length measured in units of meters, and we want to turn that into a number that is also a length but has units of millimeters. Okay? All right, now we understand a couple of things. First of all, we understand that one is going to be a multiple of 10 of the other, 10 to some power. And in this case, the multiple of 10 is 1,000. There are 1,000 millimeters per meter. Now that's a pretty simple-minded thing, but we can also actually calculate this. So for example, we start off with a quantity x that is measured in meters. And we say that there are 1,000 millimeters per 1 meter. Now you can see that I made a little matrix right here. We've separated the numbers, 1,000 to 1. There's 1,000 millimeters per meter. Okay? And this gives us the conversion factor. Now when we do our operation, we end up with being able to cancel the units of meters. We start off with a quantity x measured in meters. We can cancel the units of meters, and what we end up with here is a number with a unit attached to it. And so we have our conversion factor, and it comes out in the right units. So you take an x length measured in meters, you multiply by 1,000 millimeters per meter. This operation of division right here cancels out the meters, and you end up with 1,000 millimeters. You end up with the units that you're interested in still in the quantity. Okay, so this illustrates a couple of things. One is that you can do multiplication and division with units. If you arrange it in the right way, you can get units of an original number to cancel out so that you end up with a number with the units that you want in the end, and that's the way that you do a simple conversion. We could turn it around the other way as well. Suppose we want to look at a conversion of millimeters to meters. All right. Well, we take a quantity of x measured in millimeters, and now we know that there is 1 meter per every 1,000 millimeters. Okay. And now it's our millimeters that cancel, and we end up left with a number that has meters in the units of meters in the number, which is the one that we want. And so our conversion factor is simply, if you have x quantities of millimeters, you multiply that by 0.001 or divide by 1,000, whichever you prefer, and you'll end up with meters. So 1 millimeter, for example, gives you 0.001 meters. Okay, now that's a simple conversion. It's just to illustrate the principle, but you can get more complicated with this, and this is where carrying around a few simple conversion factors can come in handy, and also where things like handy matrices can come in handy, or conversion factors can come in handy to help you help you formulate conversion factors quite easily. So suppose, for example, you want to convert yards to another quantity over here, meters. You have a measurement in yards, you don't like the English units, and you want to turn that into a metric unit. Okay. All right, well, how is it that we do that? All right, we have a quantity x that is expressed in units of yards, and we look up a conversion factor in our table or on our internet site over here, and what we end up with here is a number that is going to be 1 meter, and in this case there are 1.0936 yards per meter. All right, and so our conversion factor, again, our yards cancel. Our conversion factor is going to be x divided by 1.0936, and that will give us a quantity y that is measured in meters now. Okay, and you can do it vice versa as well. So, for example, if you have a quantity x that is measured in meters, you can simply turn it around, turn this conversion factor around like we did before. You know you want your meters to be in the denominator, so you have 1 meter and 1.0936 yards per meter, and if you then take x and multiply by 1.0936, you're going to get a number y that is measured in yards. Okay? That is measured in yards. Okay, now that all sounds pretty straightforward, and so far there's no real advantage to doing it this way rather than just looking up the conversion factor in a table. But we can use this kind of logic and operations to enable us to calculate quite simply fairly complicated conversion factors that may not be readily available in a table or on the internet. Okay, so for example, suppose we want to convert an area measured in one system of units to an area measured in another system of units. And let's take one simple example right here. Suppose we have something that has an area of millimeters squared, and we want to convert that to a unit that is expressed in units of meters squared. How is it that we do that? Okay, now, as I said, you can do multiplication or division on units and dimensions, just as you can on dimensions. And in this case, the multiplication comes in the power. That's simply a form of multiplication. Millimeters squared is simply millimeters times millimeters. Millimeters cubed would be millimeters times millimeters times millimeters, and so forth. All right, but let's get back to how it is that you actually manage to do the conversion. Okay, so let's first of all talk about converting millimeters to meters. All right, well, we've already done that. We know that our conversion factor is going to have millimeters in the denominator. So we want millimeters, 1,000 millimeters per 1 meter. Okay, and we've seen this already. That's our basic conversion factor for converting one length to another. But now we're taking area, which has dimensions of length squared, and we're going to try to figure out a conversion factor there. So what we have to do is we have to realize that millimeters to millimeters squared involves multiplying it by itself. All right. So millimeters squared to meters squared. We take the same conversion factor, 1 times meters, 1,000 times millimeters. But of course, now look at this. We have millimeters squared over here, but millimeters here. To make those units consistent, to make them cancel out, we have to square this. All right. Same thing over here. We have to square the dimensions of meters, or the units of meters. And because you have to be algebraically consistent, you have to square all of these as well. Okay. All right. If there's 1,000 millimeters per meter, there's 1,000 squared millimeters squared in 1 meter squared. All right, now in this instance, what you have here is a conversion of millimeters squared is simply the ratio of 1 squared, which is 1, over 1,000 squared, which is 1,000,000, and the conversion factor you're going to have is 10 to the minus 6, or 1 over 1,000,000. So x times x measured in millimeters squared. To turn that into meters squared, you take x times 10 to the minus 6, divide by 1,000,000, and you end up with meters squared. And of course, what this says is there's 1,000,000 millimeters squared in a square meter. Let's have a look at a way of converting, say, a volume measured in English units to a volume measured in metric units. So, for example, let's take a volume measured in inches cubed, and we want to turn that into a volume measured in centimeters cubed over here. All right, well, this is a little bit more complicated, but in principle, it's the very, very same kinds of operations. And let's just go through this very quickly, how this happens. All right. So, for example, I said that you can often derive conversion factors by carrying around a few simple conversion factors in your head. All right, and one of the things that I have burned into my memory is the conversion between inches and millimeters. I know, for example, that there are 25.4 millimeters per inch. That's just something I've memorized, and something that you should memorize as well. So we start off by saying, well, we have 25.4 millimeters for every 1 inch. And notice here that we have a quantity measured in inches cubed. We want to have our inch in the denominator over here. All right. But again, we have to take into account that volume has dimensions of length cubed. So what we really have to do is we have to cube both millimeters and inches. Okay. And that means we have to cube the conversion factors as well. So the first step of this is to cube 25.4 divided by 1 cubed, which of course 1 cubed is 1, and that'll give us millimeters cubed per inch. We're not quite there yet because we want to convert into centimeters cubed over here. So we need a conversion factor from millimeters cubed into centimeters cubed. We want to end up with centimeters cubed in the numerator. So we multiply that by another conversion factor. We know, for example, that there are 10 millimeters per centimeter. So we start off with 10 millimeter per 1 centimeter. But again, here we have millimeters cubed, millimeters over here, so we have to cube those to make them consistent. That means we have to cube centimeters cubed. We cube both of the numbers as well, and therefore we're going to have the quantity 1 cubed over 10 cubed. Right, now let's look at what happens to the units here. All right, inches cubed is here. You can get rid of it there. It cancels out there. Millimeters cubed can be canceled out, just like a number. And what you end up with is the only unit, which is the one you happen to want, which is centimeters cubed. And now we can figure out our conversion factor. Our conversion factor to convert inches cubed to centimeters cubed is simply 25.4 cubed divided by 10 cubed. And I've worked that out. That's about, got your calculator at this point, this is 16.387 or so. But the only thing I've needed to know in this is this one simple conversion factor. How many millimeters are in an inch, okay? And so rather than having to actually memorize a specific conversion factor from inches cubed to centimeters cubed, I can actually calculate a conversion factor just by knowing how many millimeters are present in an inch. Okay, well, that's all for now, and when we come back, we'll talk about a more interesting thing that you can do with dimensional and unit analysis that can actually give you some insight into some fundamental physical principles.